Hi friends, today we are going to learn about epicyclic gear train. So before going to epicyclic gear train, let us go through the basic of simple gearing. Gear trains are a device which is used for power transmission, that it transforms power from one shaft to other shaft. For example, just to go through this figure, there is a driver and a driven, and power is transferred from driver to driven. For these two gears to mesh properly, the module of both the gear is should be same. Now what is the module? Module is nothing but the ratio of pitch circuit diameter in mm of the gear to the number of teeth of the same gear. For example, if gear 1 PCD is 100 mm and number of teeth is 25 mm, then the module is 4. Similarly, if the PCD of gear 2 is 40 and the number of teeth is 10, then module of gear 2 is also 4. So these two gears will mesh properly without any problem. So if the modules are not same, these two gears will not mesh. And for simple gearing, as shown in this figure, the speed ratio is given as N1 by N2 is equal to T2 by T1, where N1 is the speed of driver and N2 is the speed of driven, whereas T2 is the number of teeth on driven and T1 is the number of teeth on driver. This is the basic. Now, coming to the epicyclic gearing. In epicyclic gearing, there is an arm connected between two gears. If the arm is fixed, both gear A and B will work as a simple gearing. But if arm is allowed to rotate and gear A is fixed, the whole gear B will move around the A. The advantage of this epicyclic gear train is that you will get higher velocity ratio with less space. And these gear trains, epicyclic gear trains, are widely used in different mechanisms, like some planetary motion, planetary gearbox of EOT cranes. These are some practical advantages, watches, all these places these gear trains are used, where higher velocity ratio has to be transferred within less space. So normally in all the books and all the reputed author, there is a formula for solving this epicyclic gear train that is called tabular method. Here I am going to do all the gear trains with the help of algebraic method. So what is algebraic method? It's a very simple process to find the speed and number of teeth, whatever required as per the numericals. Here in algebraic method, what we will do, we will write relative speed of particular gear with respect to arm. Suppose this is the arm, and relative speed of gear A with the arm is Na minus Nr, and relative speed of gear B with the arm, it is Nb minus Nr. And as we discussed earlier in previous slide, the speed ratio is N1 by N2 is equal to T2 by T1. So here, since we have taken relative speeds, so our formula comes like this: Na minus Nr divided by Nb minus Nr is equal to Tb minus Ta. Now what is this minus sign? This minus sign indicates that gear A and B rotates in opposite direction. For example, if the gear A is rotating clockwise, then B will rotate anti-clockwise. Similarly, if the three gears are there, then one will rotate clockwise, other will rotate anti-clockwise, and suppose one more gear C is here, then it will rotate in clockwise direction again. Then this minus sign will not come. So with the coming slides, we will be knowing about this. So for the time being, just make sure this algebraic method is as simple as simple gearing. Only thing, you have to take the relative speed of the particular gear with the help of arm, and we are going to solve some set of numerical, and at the end of this video you will be able to make or solve the epicyclic gear train numerical without any problem. So just go to this figure. There are four gears: gear A and gear B and C, which is positioned on the arm. This is the arm, and an annular gear D, where teeth are inside of the gear. So in this case, how to write relative speed? So for NA, we will simply write, and suppose for example we are writing the speed ratio of A and B as simple gearing. We will write NA by NB is equal to TB by TA. Whereas for this epicyclic gear train, we will write NA minus NR divided by NB minus NR is equal to minus TB by TA. Similarly, if you want to write the speed of A and D, so the formula will be NA minus NR by ND minus NR, again minus TD by minus TA. Why minus A? Because if A rotates clock, C will rotate anti-clock, and since C and D is annular gear, so D will also rotate anti-clock. So A clock and D anti-clock, since these two are opposite direction, that's why minus sign is showing here. Similarly, for NC and ND, if NC, gear C rotates clock, gear D will also rotate clock. Why? Because this is annular gear. So here there is no minus sign. The advantage of this algebraic method is that we can write relative speed of any gear with respect to any gear until unless it is compounded. In future slides I will show. So if you go through the tabular method, you have to write each gear speed, and then it based on the formula of y is equal to mx plus c. That is little lengthier process. For example, suppose I have the gear of speed of A, and I want to know gear speed of D, then I need not to write the speed of B and C. Directly we can write a relation between A and D. This is the major advantage of algebraic method, and this is very fast. One more example with B and D is as similar as NC and ND. I have written the equation NB minus NR but ND minus NR is equal to TD by TB. So I think you understood how to write the relation of epicyclic gear train. It is as simple gear train. Only thing we have to write the relative speed with the arm and negative or positive direction based on the speed or rotation direction of speed actually. So I will take one more example. Say here there are 4 gear. Gear A is annular. Gear B and C are compounded on the same shaft, and gear D, there is a gear D and RH. Gear B and C is mounted on RH. Okay. Now here if you want to write is a relative speed of A and B, it's so simple. NA minus NR divided by NB minus NR is equal to TB by TA. No minus sign because A and B are annular gear, and the gear B speed will be same as gear speed C because they are mounted on the same shaft. And relation of C and D is NC minus NR by ND minus NR is equal to minus TD by TC, and minus sign indicates that C and D rotates in opposite. These are the basics examples. With the help of this, we can solve any numerical. With the knowledge of this much is enough to make any epicyclic gear train numerical. So now this is one planetary gear. So here I will show what is the advantage of algebraic method over the tabular method. See the planetary gear, there is A, B, C and D. There are three planetary gears. Three known as gear C. There is arm A and gear B and annular gear D. Here as B and C directly meshing and C is meshing directly, so we can escape gear C and we can write relation of gear B and D directly. That is a major advantage of algebraic method. Like I have written here, NB minus N carrier. So carrier or arm is same things. So since it is carrying 3 planetary gears, that's why it is called carrier. So NB minus NB minus N carrier divided by ND minus N carrier minus TD by TB. Why minus sign? Once again, let me clarify. If B rotates clock, C rotates anti-clock, and D rotates anti-clock because C and D's are annular gear. You know, in annular gearing, the direction of gear is same. So if B rotates clock, C rotates anti-clock, and D rotates anti-clock. So finally, B and D direction is opposite. That's why your minus sign is there. Similarly, we can write relation of C and D is very simple. NC minus N carrier by ND minus N carrier is equal to TD by TC. No minus sign because C and D is annular gear. Similarly, NB minus NB, B and D, B and C also we can write. So these are the basics of the algebraic gear. With this, we'll go to some few examples. Oh, sorry, T was missing. Now, this is the simple questions. One of the GATE exam it has come. Normally, if you go to the tabular method, you will take time, but in such an entrance exam, you will not have much time. So, to avoid that, we will go through the algebraic method and we will solve it very fast. So here the question is given like this. With the respect of epicyclic gear train as shown in the given figure, A has 75 teeth and B has 25 teeth. A is fixed. This symbol is for fixed. And B has 25 teeth as given here. A is fixed and arm C makes 5 revolutions. This arm C makes 5 revolutions. The number of revolution made by B is to be find out. It's very simple question. We simply wrote the data as given in the question. TA is 75, TV is 25, NC or NR is 5. Now we'll write the algebraic equation, that is relative speed of A with respect to arm and relative speed of B with respect to arm. So NA minus NR divided by NB minus NR is equal to minus TB by TA. Here again y minus sign because A and B rotates in opposite direction. Now we'll simply put up the respective value and we'll get the answer. NA is 0 because it is given as fixed, NR is given 5, NB we have to find out. Again NR is 5, number of teeth on wheel B is 25, number of teeth on wheel A is 75. By putting the above value, we'll get the equation and we'll get the speed of NB as 20. And again here NB is coming plus 20. That means the direction of speed of B, direction of B is same as the direction of C. Anyhow, the direction is not asked here. So the simple answer is option C. Now we'll go to the little more complex question in coming slide. So here is the question. Let me go to the figure first so that it will be easy for me to explain. An epicyclic gear train as shown in the figure is composed of fixed annular wheel A. This annular wheel A is fixed. This is the symbol of fixed. Having 150 teeth. So TA is 150. The wheel A is messing with wheel B, which drives wheels D through the idle wheel C. The A is messing with B and C the idle wheel and it drives the T. All these 4 wheels A, B, C, D is messing each other, so the module is same as I discussed in earlier slide. D being concentric with A. This D being concentric with A, this sentence have lots of meaning that will come to know now. The wheel B and C are carried on arm which revolves clockwise at 100 rpm. Here speed of arm and direction is given, that is 100 rpm. About the axis of A and D. If the wheel B and D have 25 teeth, the number of teeth on B and D is given. A already it is given 150. Find the number of teeth on C. To find the number of teeth on C, we will write the distance equation. Now first we will write the given data. This is the data given. As you know, B is concentric with A. It means the radius of D, that means this distance plus diameter of C, this distance and diameter of B, all these three together is equal to radius of wheel A. So this is what we have written, dd by 2 plus dc plus dv is equal to dA by 2. Or to make it simple, you will multiply by 2. So it will come dd, that means diameter of D, plus 2 diameter of C plus 2 diameter of B is equal to dA. And since all 4 gears are missing, so module is same, so diameter can be replaced as by number of teeth. So we can write T in place of D. So TD plus 2TC plus 2TB is equal to TA. Here number of teeth of D and B and A we know, so we can simply find number of teeth of C, and which is equal to 30. That is the first answer. Simple. Now we have to find the speed of C. Here it comes the advantage of algebraic method. If you go to the tabular method, we have to write the big table with the linear process, and you have to write the speed of each wheels. Here, since we know the speed of A, we will simply write equation between A and C. That is NC, relative speed of C with R, NC minus NR by NA minus NR is equal to minus TA by TC. Why minus? Again, if C rotates clockwise, B will rotate anti-clockwise, and since A and B is annular gear, it will also rotate anti-clockwise. So A anti-clock, C clock. So A and C in opposite direction, that's why it is showing minus. Clear? Now simply put up the value and get the answer. NC we have to find out, NR is given 100. Clockwise we have taken minus, plus. You can take minus also based on our wish. Only thing we have to adhere with the direction. So NC you have to find out, NR is given 100, NA is fixed, so here we have put 0, again an arm is 100, TA is number of teeth on A, that is 150, and TC 30, just now we have find out. By solving this, we get the speed of NC by simply cross multiplication. NC is 600 rpm, and since it is going plus direction, so NC will be the same direction of arm. Simple question with the help of algebraic method we have solved without much difficulty. Now we'll go to the one more question with little more complex with compounding and all. Okay, so just have a look of next question. Figure. First let me put up the figure. It's a big figure. I think the number of wheel itself is more, but okay, we'll take advantage of the algebraic method here once again, because if you want to go for tabular method, it will be very long, and the method itself you have to remember the formula, all this thing. So okay, line by line we'll read the question. A has 40 teeth. Where is the gear A? Here A, which is fixed gear. This symbol is for fixed. It has 40 teeth. Is messing with C. C and D is compounding, and D message with E. E and F is compounding, and F message with gear G, and here gear C message with B. Wow, very good question. Okay, number of teeth are given, so we'll write the arm rotates at 100 rpm in clockwise direction. It is given. Determine the speed of gear C, E and B. Three speed you have to find. First we have to write the given data. This is the data. TA is 40, TB is 80, TC is 20, TD is 50, T is 20, TF is 40, TG is 90, NA is fixed, so it is 0, NR is minus 100. We have taken here clockwise minus. Normally we will take clockwise minus, anti-clockwise plus, but you can take accordingly. It's not issue. We have to find speed of NC, NV and NE, taking anti-clockwise direction positive. So to find out, A and C is direct meshing here. So we can write the equation NA minus NR divided by NC minus NR is equal to minus TC by TA. Why minus? Because A and C is direct meshing, so it will rotate in reverse direction. So putting this value, we will find NC. See, NA is 0, NR is minus 100 because you have taken anti-clockwise, anti-clockwise direction positive, so it is given clockwise, so it is minus 100. All the data NC we have to find out, and RME again 100, and TC by TA we have put the value. TC is 20 and TA is 40. By solving this equation by simply cross multiplication, we found the speed of NC minus 300 rpm. Minus sign indicates clockwise because positive side we have taken for anti-clockwise. Simple NC in a single line we have found out. Now we have to find the speed of B. We have to find the speed of B. So NA and NB, we will write equation because direct matching A is matching with C, C is matching with B, so we can write the equation. Here one thing to be noted for algebraic method, what caution we have to take. B and C is compounding. C and D is compounding, and that means on safe shaft. So C and D we cannot write the relation because C and D will have same speed. Moreover, you cannot write the relation of A and E also because there is a compound, and compound means breakage here. That is the only thing you keep in mind. You cannot write relation of A and E. Okay, because C and D is compound. If no compounding is coming between, there is only one wheel, then you can write the algebraic equation. Now here A and B. NA is 0, NR already we know, and NB we have to find out, and number of teeth for B is 80 and number of teeth for A is 40 is given. So I was simply putting the value, we got the NB speed of 150 rpm. Minus sign indicates rotation clockwise. So it is very simple method, simple in one line we can get the answer. Okay. Similarly for D and E, where it goes gear D, this is gear D and this is gear E, direct matching, so it will be minus, and we will simply put all the value. ND is given minus 300, ND it is not given actually. ND minus 300 we have put from NC because already we have found out NC is minus 300, and C and D is compounded on safe shaft. See, this is gear C and this is gear D compounded on safe shaft, so both the speed will be same. So I have put ND is minus 300 and already we have found it. Arm is minus 100, NE we have to find out, again arm is minus 100, and TE is 20 and TD is 50. That's it. By simple cross multiplication, we found the speed of B 400 rpm anti-clockwise because it is showing positive direction. Yes, so positive direction we have taken anti-clockwise in this question. Simply we have find out the speed of C, E and B with simple 3 lines. This is the algebraic method for epicyclic gear train, where the questions looks very clumsy and looks like big problem, but with the simple 3 line this we have solved. Similarly, we will go to the next question. This is very interesting question. Planetary gearbox, widely used especially in cranes. So this is an epicyclic gear train of an electric motor, is shown in figure. The wheel S has 15 teeth. The wheel S, this is the wheel S. S means sun wheel here normally. Has 15 teeth. TS is 15 and is fixed. It is fixed to the motor shaft rotating at 1450 rpm. That means NS is given 1450 rpm. The planet P has 45 teeth. There are 3 planetary wheels and each is having 45 teeth with fixed annulus A and annular gear A. This is annular gear A and rotates on spindle carried by on arm which is fixed to the output shaft. This arm is fixed to the output shaft. Okay. The planet P also gears with the sun wheel S. Planet P gears with the sun wheel S. Find the speed of output shaft. That means we have to find the speed of arm. Okay. So first we will write the given data. TS, sun wheel speed, number of teeth is given 15, TP is given 14, that is planetary wheel number of teeth. NS is 1450, that is sun wheel speed. NA is fixed, so it is 0. Here it is written fixed annulus A, so it is 0. And now we have to find out. So what do you think? Whether this planetary equation we have to write all the speed? No. Simply we will write the relation between S and A without bothering anything about the P. What we will do? We will write speed of S and A, but before that we have to find number of teeth for A. How to find out? Simple, like previous example we have done. ds by 2 plus DP is equal to dA by 2 multiplied by 2 to each side. So ds plus 2 dp is equal to dA. Convert in terms of ts, means number of teeth, because modules are same. So ts plus 2 tp is equal to ta. Now value. So by putting the value of ts and tp, we will get the number of teeth on way. That is 15 plus 90, that is 105. So once you found the number of teeth on A, now it is very simple to write the equation between S and A. So you simply write the equation of S and A, NS minus NR divided by NA minus NR is equal to minus TA by TS. Why this minus sign? Because if S rotates clock, P rotates anti-clock, and since P and A are annular gear, so A also rotate anti-clock. So eventually A and S rotates in opposite direction. That's why this is minus sign. This is the only thing you have to keep in mind. Now we'll simply put the value and get the answer. NS is given 1450, NR we have to find out. NA is fixed, so 0, and NR and TA is 105 and TS is 15. By simple cross multiplication, we'll find out NR is 181.3 RPM. And since it's coming plus direction positive, so the speed of arm is same as the speed of S, that is sun gear S. So like this simply we can make the planetary gear train numerical. So I hope I have covered most of the thing, like compounding and planetary gears and simple gear with epicyclic. So with this much knowledge, I hope you can make numerical of any gear train having epicyclic gearing with less effort and without much problem. So after completion of this, we'll go with this is only for ready reference. This is one practical example, one of the EOT crane planetary gearbox, how it will be look like this on 3D image. This is the motor shaft. This gear you are seeing the motor shaft. This gear is motor shaft, and this is shaft, and this particular shaft is locked during micro. This is a micro planetary gearbox, and this micro white input shaft. This is from motor, and this is going to the main motor. This is a crane gear train. So I have now 3D we made in 2D, simple as earlier as we have made like gear train numerical. Similarly we will make here also. All the teeths are given. Gear A is messing with the carrier wheel, and carrier wheel is now carrying this planetary gear P2. There are 3 numbers on this side, and again P1 there are 3 numbers this side, and one sun gear S2 and S1, main motor shaft, shaft lock, and all the speed and teeths are given. Here is speed of carrier wheel, it is given minus 9 clockwise. I have taken negative direction, and simply we can find the speed of carrier with the help of A, because these two are simple gearing. There is no epicyclic arm here between A and C, so active minus sign is not required here. simple formula by N1 by N2 T2 by T1, we have found the speed of carrier. Once the speed of carrier is known, we can find the speed of planetary gear, index gear, sun gear, as done earlier example. So friends, just go ahead with different type of numerical, solve it with this basic, and get full confidence on epicyclic gearing. And now you need not to leave any question of epicyclic gearing. It's very simple. So again, next video with some new concept, with new chapters, some other subject, I'll come to you. Thank you. Bye bye.